AP Calculus, welcome back. This is assignment number 4, and I'm just going to put 004 over here on top. And we are going to review a majority of the parent graphs, a lot of the patterns, the graphing that you guys have learned over the years, because we are going to be analyzing almost all of them actually in this calculus class. There's going to be a lot of flipping back and forth because I'll be presenting some things over here, and then afterwards, we might do some notes parts over here, and then on the last videos we will go back to domain and range. So it will look like in the last videos it's like, oh wait, we're back on the first page again. We're jumping a lot of back and forth the way I presented this material. So we'll just do the parent graph patterns first. We'll jump into a couple of the exercises, notes over here, and then on the last videos we'll do domain and range. Let's start with lines first. You guys have been graphing lines since pretty much almost the beginning of time. F of x is equal to x. Remember f of x, it is a name, so y equals x. If you feel a little bit better with that, that's fine. Your slope is going to be over here. It's a 1. So you are going to go 1 up and then 1 to the right. Okay. So 1 up and then 1 to the right, and you have a positive increasing line. Okay, increasing. As opposed to number 2, negative x, you have that negative 1. From the 0, 0, you're going to go 1 down and then 1 to the right. Decreasing line. Okay, looks like okay. Apologies for that. Negative 1x. Okay. We also have horizontal and vertical lines as presented over here. So if you have something like f of x is equal to 2, or the same thing as y is equal to 2, what this really means is if you take a look at your values here, your coordinate points, this is 1, 2, this is 3, 2. So the reason why it's called f of x is equal to 2 or y is equal to 2 is all of your y coordinates are 2's. When you connect the dots, it makes a horizontal line. As opposed to number 4, your vertical line, an equation for that is x equals a, whatever number it is, so x equals 2. Let's take a look at some of the values over here. This is 2, 1, and this is 2, 3. So take a look at the x values. All the x's are the same. When you connect all the dots, it makes a vertical line. So hence, x equals 2. Okay. 5 and 6, you have your positive slopes again. So here is a specific example. Your y equals mx plus b. Your b is negative 5. So you start on the y-intercept at 0, 5 right over here. And you're going to go 3 up, 4 to the right. For this class and always, I think for us, we're always going to go to the right no matter what. The negative will determine if we're going to go down. So from here, you're going to go 3 up, 4 to the right, and it will be the same pattern throughout. As opposed to number 6, your y-intercept is positive 3, and then your slope is negative 2 over 1. So the negative will dictate that we'll go down, and we're going to go to the right no matter what. Okay, 2 down, 1 to the right, 2 down, 1 to the right. Okay, before we move on to parabolas, I think we can jump on into some of the graphing problems. So let's go and jump. Just follow me to number, I think we can do 44, 45, and 46 already. So let's go do that right now. 44, it is a line. F of x is equal, we just have an x, so our slope, our y-intercept is negative 1. So let's graph that. I'm just going to use red, negative 1. And then we are going to go 3 up and then 5 to the right. Let me see if I have some sort of, yeah, I have my bus cast over here. So we're going to go 3 up, 5 to the right. 1, 2, 3, 1, 2, 3, 4, 5. 2 points should suffice. You can also go totally backwards, 3 down, 5 to the left. I think that should do it. All right, let's do 45. It is positive 1, so this is going to be your y-intercept. Your slope, there's a negative. Okay, so it's going to be negative 1 over 1. You're going to go 1 down and then 1 to the right. From the 0, 1. 1 down, 1 to the right. Okay. I think we can do one more and then we'll go back to the parent graphs on the first page. 46, we got to graph these two on the same Cartesian plane or the same xy graph. Y equals -1. So to graph that, I would just go on the y-axis -1 and then make a horizontal line. So this is y equals -1. And then x equals -1. I start on the x-axis, plot -1, and then go up and down. And you know what? I'm just going to use a different color. So I'm just going to use the light green over here. And this is x equals -1. Okay. So all the graphing that you've learned from, 6th, 7th, 8th grade all the way to now, done in 5 minutes. 5 minutes and 30 seconds. Okay. All right. That's that. Let's go back to the first page now, and then we're going to do parabolas. I think if you've taken Algebra 2 with me, I usually teach it with patterns, but if not, here are the patterns. And how I got these patterns is plugging in the numbers in place of the x value. Okay, so we have x over here, and then you have your y value, or I'm just going to put x squared. Okay. And this is how I'm getting these patterns. If you plug in 0 for x, what is 0 times 0? It's just going to be 0. Okay. Then you plug in 1. What is 1 squared? Well, that's 1. Okay. Then now plug in 2. What is 2 squared? That's going to be 4. Okay. Now you plug in -1 for x over here. That's -1 squared. That's a 1. And then after that, -2. Be careful. -2 squared is equal to 4. So this is going to be your general pattern for your x squared graph. So what that means is you're going to start on the vertex. Start on the vertex, wherever that is, and then you're going to go 1 to the right, 1 to the right, 1 up, 2 to the right, 4 up, 1 to the left, 1 up, 2 to the left, 4 up. It's a face-up parabola because your a value is positive, so it should be looking like a U shape. I just want to see if we have a specific example for that I put in. I hope I did. Actually, yeah, we can. So here's that pattern. Let's jump to, so like I said, this video, we're just going to be jumping a lot. Let's just jump to number 47. Okay. So for number 47, it is an x squared graph, which will follow the pattern of number 7 over here. We just got to figure out where our vertex is. So for our vertex, I can rewrite this as x minus 0 squared minus 2. Here's a reminder one more time on getting the starting point of the vertex. It is the opposite of what you see by the x inside that parentheses, and this one is the same or as is. Okay. So, well, I mean, there's no really opposites of 0, so it's just going to be 0. And then this will be -2. So this is going to be your vertex or your starting point of that. So let's go graph it, 0, -2. Okay. And then you're going to follow the x squared pattern, which is on number 7 on this specific worksheet. Okay. So from the vertex, you go 1 to the right, 1 up, and go back to the vertex, 2 to the right, 4 up. Okay. 1 to the right, 1 up, 1 to the right, 1 up. Go back to the vertex, 2 to the right, 4 up. 1, 2, 1, 2, 3, 4. Go back to the vertex, 1 to the left, 1 up. Go back to the vertex, 2 to the left, 4 up. 1, 2, 1, 2, 3, 4. Okay, so that's what I mean with the patterns. I like to teach the patterns this way just because then you're not plugging in every single number there is, like, plug in 0, plug in 1, plug in 2. You just find the vertex as a starting point and then just follow this pattern. It prevents you from plugging in numbers, and it's a little bit more visual, especially for the visual learners over here. Then you've already graphed that parabola. Okay, so this is how I'm going to be teaching. So starting from number 7 on, I'm just going to show you guys the patterns, and then afterwards, what you have to do now is just find the starting point and then follow that pattern for that graph. Okay, let us do number 8. So number 8 is an inverted parabola. I mean, the only difference is it's facing down. And so how I grab the patterns again is I plugged in numbers. I'm just going to plug in numbers just one more time, and then afterwards, maybe I won't be plugging in too much. Okay. I want to remind you that this is -1 times x squared. Okay. Plug in 0. You got to do exponents first. 0 times 0 is 0. Times -1 is going to be 0. Okay. Let's plug in 1. You have to do this first. 1 times 1 is 1. Times -1 is -1. Okay. Let's plug in 2. 2 times 2 is 4. Times -1 is -4. Okay. -1 times -1 is 1. But then you're going to multiply -1 again, so that's going to be -1. Sorry, -2 squared. -2 times -2 is +4, but you're still going to multiply that by -1. This is going to be -4. So this is going to be your pattern for this. You're still going to start on the starting point or the vertex. And then this is going to be your pattern. You're going to go 1 to the right, but this negative dictates that you're going to go 1 down. You're going to go 2 to the right, and then 4 down. 1 to the left, 1 down, 2 to the left, and then 4 down. Okay. All right, let's move on to a little bit more patterns. Two to the x squared. Zero, 1, 2, -1, -2. I don't always plug in these numbers, but those are really good numbers to start off with. You plug in 0, 0 times 0, 0 times 2 is 0. Okay, you plug in 1. 1 times 1 is 1, times 2 is 2. You plug in 2. 2 times 2 is 4, times 2 is 8. You plug in -1. -1 times -1 is 1, times 2 is 2. And then you plug in -2. -2 times -2 is 4, times 2 is 8. This is your pattern for your 2x squared graph. I'm going to do these two patterns, and there's a specific example for number 10, so we'll jump at that afterwards. Okay, so you're going to start on the vertex, wherever it is, and then you're going to go 1 to the right, 2 up, 2 to the right, 8 up, 1 to the left, 2 up, 2 to the left, 8 up. All right, let's do number 10. Zero, 1, 2, -1, -2. Let's plug in 0. 0 times 0. 0 times -2 is 0. Okay, just be careful with this. Maybe I'll just somehow just write my answer over here. 1 times 1 is 1, times -2. This is going to be -2. 2 times 2 is 4, times -2 is -8. -1 times -1 is 1, times -2 is -2. -2 times -2 is 4, times -2 is -8. So this is going to be your pattern for the -2x squared graph, and we have a specific example for that actually. So your pattern is going to be, start from the vertex, you're going to go 1 to the right, and you're going to go 2 down this time, because it should be facing downwards. Okay, go back to the vertex, 2 to the right, 8 down. 1 to the left, 2 down. So anytime you have negatives over here, you got to go to the left. Okay, and then this is going to be 2 to the left, 8 down. Okay. I'm going to stop the video after we do this next example, and then we'll move on to the next, okay? So this is number 10's pattern. Let's go jump to number 48, I believe. Yeah, 40, well, actually 49. Yeah, 49. We'll do 48 in a little bit. Okay. So take a look at number 49. Okay. First, let's start off where we have to start off, your vertex. Okay. So take a look at your vertex. So this number over here does not dictate the vertex. It's always whatever's inside with the x, and then the outside number over here, your h and k. So remember what I said, you have to go opposite of what you see, and then over here is the same, as is. So opposite of positive 1 is going to be negative 1. And then the same, it's going to be positive 1. So this is going to be your vertex, your starting point. So negative 1, comma 1. So negative 1, comma 1 is right over here. And then what pattern are you going to follow? You're going to follow the negative 2x squared pattern. Negative 2x squared pattern. Okay, why is that? Because you have a negative 2, x squared. And then I'm just going to write that pattern again one more time. You don't have to rewrite it, but I think just for notes purposes. So 1, 1, 2, 4, 1, 1, 2, 4. Oh, sorry, I looked at the wrong one. It should be the 8s, okay? 1, 2, 2, 8. 1 to the right, 2 down, 2 to the right, 8 down, 1 to the left, 2 down, 2 to the left, 8 down. So just follow that starting from the vertex, and let's do it. So from the vertex, negative 1, comma 1, go 1 to the right, and then 2 down, 1, 2. Go back to the vertex, go 2 to the right, 8 down, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. Go 1 to the left, 2 down from the vertex again, 1, 1, 2. Okay, that's done. And then now 2 to the left, 8 down, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. If you guys already know that parabolas have that mirror reflection across the vertex, so these 2 points and these 2 points respectively should be evened out from the vertex. Anyways, we're going to graph that. Okay, I'll see you guys on the next video.